This conference will now be recorded.
Okay. Uh, my name is Srinivas. So I'll be giving you a brief about the career opportunities in VLSI. Uh, so as part of this lecture, we will be talking briefly about what is specifically VLSI domain, what are the two aspects in VLSI, what is front-end domain and what is back-end domain. And we'll also be talking about what kind of skill set you require if you want to get into front-end domain, and what kind of skill set you require to get into back-end domain, and what are the career opportunities in both front-end and back-end domain also we'll be talking about. So first, let's go through the agenda. So first, let's start off with understanding an electronic system. Then we'll be understanding the difference between VLSI and embedded systems. Then we'll go through VLSI design flow. As part of that, we'll try to understand what is VLSI front-end domain and what is VLSI back-end domain. Then we'll talk about different job roles in VLSI. I mean, when you want to get into VLSI, what are the different types of job roles that are there in VLSI domain? Then we'll talk about what kind of skill set is required for getting into VLSI job. Then we'll talk about the career opportunities in VLSI. I mean, which domains have more opportunities from a fresher perspective. We'll talk about that. And we'll also talk about how to choose the right domain. Like many of you are probably pursuing a third year or fourth year of your BTech, or some of you might have completed even the BTech. So how do you choose a right domain? We'll talk about that. Then we'll also talk about how do you prepare for the job. I mean, let's say you are in 3-2 right now, or 3-1 or 3-2. So how do you start preparing for the job? We'll talk about. Then we'll be talking about why should you pursue a career in VLSI. Then we'll talk about I'll take any question and answers from your side. So first, just a brief about myself. Uh, my name is Srinivas, and I am the founder of the VLSI Guru Institute. I have a dual degree in VLSI design from IIT Madras. I'm 2005 passed out, and I have around 12 plus years of teaching experience, and I have around 14 plus years of industry work experience. First, let's get into the today's agenda. Let's start off with understanding electronic systems. Can someone tell me what do you understand from the term electronic system? What consists of an electronic system? When I say mobile phone, what is all there in the mobile phone? Is it only the hardware? I mean, is it only the hardware that makes an electronic system? Or is there anything that will collectively we call as electronic system? If you say your mobile phone or your laptop, any electronic system, okay, it consists of multiple things. I mean, what comes to your mind whenever we say electronic system? Let's say if we talk about a mobile phone, what comes to your mind is only the hardware, right? I mean, the one you see, and then what is inside that, something that constitutes the mobile phone hardware overall. But if you look at it at a with more finer details, the hardware alone is not the electronic system. uh, there are many things that makes up the electronic system. For example, a mobile phone. And there are many things that makes up what is mobile phone. What is the first thing? At the very basic level, you have a hardware, which constitutes of different types of chips, processors, the screen, the USB ports, camera, sensors, audio, different components that make up the hardware. Just as a plain hardware, the mobile phone doesn't work. On top of the hardware, you need few other things. See, there are other things which we don't see, but they are required for mobile phone operation. Can someone tell me, other than hardware, what else do you need for mobile phone to work? Let's say as soon as the mobile phone is manufactured, can I directly use it? No, right? You will need some system software, like someone has pointed. What else do you need? Other than the hardware, other than system software, what else do we need? What do we need? The OS. Okay. So you need the OS. It could be Android or iOS, anything. Other than that, you need drivers, which work on top of which interface between hardware and the operating system. Anytime the communication happens between hardware and the operating system, it happens through drivers. Let's say this is the hardware, this is the operating system. So in between you have one layer called as drivers. DRV here stands for drivers. So this is the interface between operating system and the hardware. So any communication that happens from operating system hardware happens through the driver. Next, then you have applications which are running on top of the operating system. So now tell me, how many layers are there in an electronic system? If I talk about electronic system, totally how many layers are there? Totally 4 layers are there. At what is there at the most basic level? Tell me what layer is at the basic level. At lowest level, what layer is there in the electronic system? You have the hardware. Tell me what is there on top of hardware? You have the firmware. These two connect. Then on top of firmware, what is there? Can someone tell me? On top of firmware, what do you have? This is firmware or drivers. You have the please please be in mute. Please be in mute. Please be in mute. Bharat Kumar, please be in mute. Okay. So coming back to the topic, there are 4 layers. At basic level, you have hardware. On top of that, you have the firmware. On top of firmware, you have the operating system. On top of operating system, you have the application apps, the apps that we are using. Okay. So the same topic, let's summarize in the next slide. So mobile phone has 4 layers. The hardware. Can someone tell me what is that person is called as who works on the hardware development? Who is the person who works on developing of hardware? Of course, he will be called as hardware engineer, or in our case, we can specifically call him as VLSI engineer. I mean, either you call them as hardware engineer or the VLSI engineer. So the VLSI engineer is responsible for development of the hardware. Okay. Next, the thing is drivers or the firmware. Can someone tell me who is responsible for developing of the drivers? So what is that person is called as? Like hardware is developed by VLS engineer. So who develops the firmware? It is not the software engineer. That person is called as embedded system engineer. The person who develops the drivers or the firmware is called as embedded system engineer. So I hope you understand the difference between VLSI and embedded systems. Next, we have operating system, something like Android, iOS, Windows, Linux. Who develops operating system? What is that person is called as? That person is called as the software engineer. Then we have, at the very top level, you have applications, that is the apps in the mobile or applications that we install in laptop, like for example GPay, Google Map, WhatsApp, everything is an application. So who develops these applications? It can be called as software engineer or the app developers. So this is how all four layers are there. All four layers are essential for electronic device to work. I mean, whatever electronic device we have, these are all these four layers are required for electronic device to work. Let's take one simple analogy to understand the concept of electronic systems. You consider a bus with passengers. Let's say you are going in a bus, there are other passengers also, right? What else other than passengers, what else the bus has? Tell me. Other than the passengers, who else will be there in the bus? You need a driver, and who else you require? Other than driver, who else will be there? Driver and the conductor, right? So the bus will be there. Bus will be like the hardware. The bus is the physical element that is doing everything, that is the hardware. Then you have the driver. This driver is nothing but the firmware or the drivers. That's why the term driver came into picture. What is the role of a driver? Tell me. He controls the bus. He decides, the driver decides when the bus should stop, when the bus should turn, or when the bus should be accelerated. Everything the driver decides. Then you have what? The conductor. So the conductor is kind of playing a role of a operating system. Any questions you have? See, conductor is playing the role of a operating system. Then you have got passengers. What does passengers do? Passengers are like applications. Okay, so this is how you can correlate. Now let's take one example. Okay, one use case here. In the bus, a passenger wants the bus to stop. As a passenger, like you want the bus to stop. Will you go and apply the bus to the will you go and apply the brake to the bus? Tell me. You are sitting in the bus, you want the bus to stop. What do? Will you apply brake to the bus? No, right? You cannot. You don't directly control the bus. So what do? Whom do you tell to ask? Whom will you ask to stop the bus? To whom you will tell to stop the bus? You will tell to the conductor. What conductor will do? Tell me. He will tell to the driver. What driver will do? Driver will control the bus. So essentially, this is how the communication happens between the different layers in the electronic system. The passenger will talk to conductor, conductor will talk to driver, driver will talk to the bus. So you inform the conductor informs the driver, driver will control the bus. See, driver has some controls like the brake, accelerator, clutch, gear, different things through which he controls the bus. This is exactly how electronic systems also work. For example, an application layer wants to talk to hardware. It doesn't directly talk. It talks to the operating system. Operating system talks to firmware. Firmware talks to the hardware. Now, mostly what is relevant, like all of us are either ECE or triple E students, right? Or some of you may be from instrumentation engineering also. Is there anyone from other branches attending this session? For us, these two domains are more relevant, either hardware domain or a firmware domain. Generally, you don't have to get into OS and application because this is done by software engineers mostly. So I hope you have understood the difference between VLSI and embedded systems. I hope you also have understood the different layers in the electronic system and how they interface with each other. Now let's understand what exactly do we mean by drivers. It's like you would have heard, right? People saying USB drivers. Have you heard USB drivers? uh, like Wi-Fi drivers. I mean, the modem driver, different component drivers will be there, like SSD drivers. Different drivers will be there. You would have definitely heard USB drivers. Okay, when we say driver, what exactly do we mean by driver? Can you tell me? I'm At times I'm asking the questions to make this session interactive. Please participate. Even if you tell something wrong, there is no problem. We just want the session to be interactive. So coming I mean so Likita, here we are talking about the drivers from a electronic system perspective. So let's try to understand what exactly is the driver. So driver, for example, when you connect USB device to the laptop, let's say this is your laptop to which you have connected a pen drive. Okay, it will driver will tell how this communication should happen, like what kind of packet to generate, when to generate the packet, how when packet comes, how to process that packet. That whole decision making is done by the driver. Understood, right? The communication between the laptop and pen drive happens through some packets. So even when I'm connected pen drive, there is a transfer happening between pen drive and my laptop. So the drivers will indicate how the packet should be created, what type of packet should be created, when the packet comes, what kind of packet, how the packet should be processed. For example, in USB, there will be different things like bulk transfers, interrupt transfers, isochronous transfers. Let's not get into all these technical things. Let's not get into it. Just understand that the drivers are responsible for deciding the level of communication that should happen between the how the communication happens between the my system and the device. So when USB device is connected to the laptop, USB device gets detected. So then we start doing the transfers to device. So essentially driver is nothing but a set of assembly instructions. You would have studied, right? 8085 or 8086, one of those things. So you would have seen assembly instructions in that, the move, add, sub. You would have seen such kind of assembly instructions. Driver essentially consists of these kind of instructions which will get executed when you run some application, right? When you run something related to the pen drive, these assembly instructions will get executed. So the embedded system engineer develops these drivers. Okay, which language does he use? Which language does embedded system engineer use to develop the drivers? He uses embedded C language. There is a language called as embedded C language. I mean, one type of mod modification of the C language, which is called as embedded C. So he will use embedded C language to develop the USB drivers. Essentially, it's a C language only. Okay. Now, the embedded system engineer is not responsible for development of the hardware. Understand? The embedded system engineer is not responsible for development of hardware. One more thing, if you I hope you are able to see the entire screen. In case you are not able to see the entire screen, there is an option in the somewhere in the at this point of your screen, that is in the top middle. There is an option to hide everyone. If you see who is presenting, or some option will be there. When you do the drop down menu, there is an option to hide everyone, so your screen will become big. Overall what your my presentation will come in a full screen format for you. Okay. Coming back to the session discussion, so I was telling you that embedded system engineer is not responsible for development of hardware. So what is his role? Development of drivers, or we can call them as firmware. So what is the role of a VLSI engineer? VLSI engineer is the hardware engineer responsible for development of hardware. Okay. Now, can you tell me which language does embedded system engineer use? Which language does embedded system engineer use? Embedded system engineer uses embedded C language. Okay. Which language does VLSI engineer use? The VLSI engineer uses HDL languages, either Verilog or VHDL languages. So using these languages, Verilog and VHDL languages, the VLSI engineer develops the hardware. Okay. He implements the code, which we will talk about as we go forward. Okay. So primarily, I wanted to tell you what is the role of what is embedded system engineer does, what does VLSI engineer does. Next. Please be in mute. Lokesh, please be in mute. Lokesh, please be in mute. Okay. We'll take one example to understand what is a driver. Let's say in the current mobile screen turn off time is 30 seconds. Let's say in my mobile, the currently my mobile screen turn off time is 30 seconds. I want to change it to 60 seconds. Means what? If I don't use the mobile, it'll go off in 30 seconds, right? Screen will turn off. So how do you do? We don't directly do it at the hardware level. So what we do, we go to the application. You run an application. You directly don't interface with hardware. So then how do we do? We open the settings. That is, at the application level, you're opening the settings. Then you change number 30 to 60 there. In the application level, you change number 30 to 60 there. What is happening? This will create an instruction. This will create some kind of processor level instructions. This changing of 30 to 60 will result in driver executing some instructions. Understand? Whenever you are changing number 30 seconds to 60 seconds, the drivers responsible for that will generate some processor specific instructions, assembly instructions, which will generate, which will do the register access in the design. In the hardware, these instructions will cause the number 30 to be changed to 60. That is how your mobile phone time changes from 30 seconds to 60 seconds. So in this slide, we are trying to understand what is the role of a driver. Okay. So I hope you got a feel of what is meant by what is an electronic system. So in summary, I hope you have understood what is an electronic system, what are the different layers in an electronic system. Okay. And what is the role of a VLSI engineer, and what is the role of a embedded system engineer. Okay. Now let's move to the next thing. So I'll try to keep it brief, maybe half 45 minutes we'll talk about this. Then we'll move on to understand the career opportunities in VLSI. Okay. So first, now let's talk about different design styles. I'll try to keep it brief. So there are two ways in which chips can be manufactured. First, let's understand what is VLSI. VLSI stands for what? Very large scale integration. Can you tell me what are we integrating? When you say very large scale integration, what do you think we are integrating? Integrating means what? Putting together things, right? So what are you putting together? You're basically integrating transistors. I mean, the large, very large scale integration of the transistors is what we call as the VLSI. So since we are integrating billions of transistors, it is called as very large scale integration. The VLSI chips can be developed in two styles. There are two major styles of developing VLSI chips. Can someone tell me what are the two major styles in which the VLSI chips can be manufactured? One is the ASIC style, one is the FPGA. ASIC stands for what? Application specific integrated circuits. FPGA stands for what? Field programmable gate array. In ASIC, hardware is developed for a specific application. When the hardware is developed targeting a specific application, means let's say you go to Qualcomm. Are you all familiar with Qualcomm? Are you all familiar with the company Qualcomm? Can someone tell me what does Qualcomm do? What kind of chips does Qualcomm manufacture? What kind of hardware or the chips does Qualcomm manufacture? Can someone tell me? It manufactures mobile phone SoCs. Whatever mobile phones you are using, in that there will be chips. Lot of it, many of those chips are manufactured by Qualcomm. Then there are companies like MediaTek, then company like Samsung, Apple. So these are the various companies which manufactures the chips that goes into the mobile phones. Okay. Now, when Qualcomm manufactures a mobile phone chip, can you use it as a laptop? Is it possible to use your mobile phone as a laptop? Tell me, is it possible to use your mobile phone as a laptop? Not possible, right? Mean mobile phone chip will only work like a mobile phone. That is why it's called as application specific. It will only work specific to the application only. For example, Intel. Can someone tell me what does Intel do? What does Intel do? Intel manufactures the processors, right? The different types of processors. Okay, so which will go into desktops and laptops. Can I use that chip as a mobile phone? No, right? Whatever chip they develop, can I use that as a mobile phone? No, right? Because the Intel chips won't have the modem. So that means whatever application Qualcomm develops, it is specifically developed to work like a mobile phone. Whatever application Intel develops, it is specifically developed to work like a desktop or a laptop. That's why these are called as application specific. Then, what is FPGA? FPGA stands for Field Programmable Gate Array. Same in case of field programmable gate array, same FPGA board can be programmed to behave like different applications. In this case, same FPGA board can behave like a mobile phone. Same thing can be programmed to behave like a laptop chip. Okay. By programming it differently, by using the different way of programming, you can make the same FPGA board to behave like laptop chip, same thing to behave like a mobile phone. Understood, right? Okay. Though I mean, tell me, going by this, which one is better? Do you think FPGA is better or ASIC is better? Which one do you feel is better, ASIC or FPGA? Actually speaking, FPGA looks better, but it is more costly. FPGA is lot more costly. If FPGA cost, let's say, uh, 30 rupees, same ASIC can be done in 10 rupees. Now tell me which one is better. To manufacture the same kind of functionality using FPGA, it will cost 30 rupees. ASIC will only cost 10 rupees. So which one do you think companies will prefer? Which technology do you think companies will prefer? Companies will prefer ASIC because it will cost less. So the simple logic is, not going deep into it. If we want to manufacture in less quantity, FPGA is better. Maybe less quantity means what? Less than thousands, few thousands. Means you want to manufacture only in hundreds or thousands. Few hundreds or thousands. FPGA is a better option. If you want to manufacture in bulk, large quantity, like lakhs or millions, then ASIC is a better option. Okay. So just to give you a simple example, mobile phone, a mobile phone, do you think will the company use FPGA option or ASIC option for that? Which technology do you think, which type of manufacturing style do they, I mean, which type of design style they will use, ASIC or FPGA for mobile phone? ASIC will be used because ASIC, mobile phone need to be manufactured in bulk, either lakhs or millions need to be manufactured. So they will go with ASIC. So based on the specific requirement, they will choose either to go with ASIC or they either to go with FPGA option. So I have few slides which, let's not get deep into it. Okay. So the summary is what? Ba- uh, Based on how much you want. Do you want bulk production or do you want limited production? There they choose whether to go with ASIC or FPGA. See, ASIC comes with some advantages and FPGA also has some advantages. So let's try to understand what are the advantages of ASIC over FPGA. ASIC advantages are like, first of all, it is cheaper, almost like one half or one third compared to FPGA. It consumes less die area, hence it is cheaper. I mean, why is it cheaper? Generally, it can be manufactured in a smaller area compared to FPGA, hence it is cheaper. It provides flexibility to customize the design features. I mean, ASIC provides flexibility to customize the design features. Means what? You can develop the mobile phone as you want. I mean, whatever is the requirement, you can develop accordingly. It is power efficient. ASIC is what? Power efficient. ASIC can work, most importantly, ASIC can work at higher frequencies compared to FPGA. Hence, it gives better performance. So let's summarize all the five advantages. What are the first advantage? Can you tell me? What is the first advantage of ASIC over FPGA? Cheaper, less area, flexibility in developing that features, power efficient, can work at higher frequencies, hence gives a better performance compared to FPGA. Next, let's talk about advantages of FPGA over ASIC. See, even FPGA should have some advantages, right? See, the biggest advantage with FPGA is that if chip has a bug means what? Some wrong behavior, some functional defect is there. Let's say chip has some kind of defect. which is detected after manufacturing. Let's say you have detected after manufacturing. FPGA style will not involve big cost. I mean, FPGA style, there won't be much problem. Okay. We don't have to implement the entire flow again. Bug can be fixed in the next FPGA board. See, whatever fix you want to do, you just implement into the next FPGA board. We don't need to start everything from scratch. In ASIC, if there is a bug, we need to do the entire flow again. The biggest problem with ASIC is what? If there is a bug, we need to do the entire flow again. FPGA, that is one advantage of FPGA or ASIC. So the uh, respin cost will not be much. This is called as respin. Whenever there is a bug, you are manufacturing again, you are doing the process again. That's called as respin. RE spin. Respin. Okay. The cost of respin is very less in FPGA compared to ASIC. The next advantage of FPGA is FPGA flow is quick, because since we don't start from the scratch and the board is readily available, so that it can be completed quickly. It takes less time to develop FPGA flow compared to ASIC flow. Other advantage is FPGA is used at one stage of ASIC flow. This is fine. I mean, there is a concept called as FPGA prototyping. Let's not get into it. I hope you have understood the difference between ASIC and FPGA, and what are the advantages of ASIC over FPGA. Okay. Uh, okay. Do you have any questions related to ASIC and FPGA? Talking about VLSI and ASIC, talking about ASIC and FPGA, talking about the VLSI design flow for ASIC and FPGA. Okay. I told you, right? VLSI has two domains. What are the two domains in VLSI? The front end domain. What is the other domain? Can you tell me? The backend domain. This front end domain is similar or even same for both ASIC style and FPGA style. Understand? The front end domain flow is similar, or I would say same, for both ASIC and FPGA styles. So backend domain is where it differs. It differs for ASIC and FPGA style. Because in ASIC, everything starts from scratch. It needs to start from scratch. You don't have anything to start with. In FPGA, we already have the board available. FPGA board is already available, is already ready, is available. The floor planning, the backend flow is implemented specific to that, is implemented specific to that board. Understand the difference? We are trying to understand the difference between how ASIC and FPGA differs and what is common between ASIC and FPGA. So tell me, which domain is common for both ASIC and FPGA? Which domain is common for both ASIC and FPGA? The front end domain is same for both ASIC and FPGA. Which domain is different? Backend domain is different for both of them. The backend domain is different for both ASIC and FPGA. So let us now understand what exactly is this front end and back end. Okay. As I said, where do they differ? Majorly, they differ in the VLSI backend flow. That is the flow starting from physical design to custom layout. When we say physical design, DFT, the synthesis and HTA is where majorly they differ. Now let's understand ASIC design flow. Let's understand ASIC design flow, and then we'll also talk about what are the job opportunities in ASIC flow, in ASIC design. So, do you have any questions till this point? Do you have any questions till this point? Okay. So let's understand the ASIC design flow. To understand an ASIC design flow, let's take one analogy. Simple example. The ASIC design flow can be compared to a house construction flow. I mean, how the way the house construction goes through different stages. The same way we can correlate ASIC design flow also. So where does the house construction start? Can you tell me? At what stage the house construction will start? It starts. I'm sorry, I was disconnected for some time. Let's resume the session. Okay. So, I'm audible now? Okay. So, we were discussing about the ASIC design flow analogy. I was telling you that ASIC design flow is similar to a house construction. So, where does the house construction start with? You don't directly start constructing the floor, basement and everything. First, you start with requirements, right? You will list down what are your requirements for the house construction. So, what kind of house you want, those kind of things you will start with. Then, what do you do? The next thing, tell me. Will you directly start constructing? Tell me. As soon as requirements are there, do you directly start constructing? No, right? You go for designing purpose. You go to an architect. You go to an architect. That is the house architect. What does house architect will give you? He will take your requirements as an input. What does he give? He gives you architecture diagram and various other plans. Okay, electric, plumbing, plinth, different types of plans he will give you. So then you go to the contractor or the maestri. So what does he do? Whatever you have inputs from here, whatever output you have from here, that is input to the next stage. So that means what? This is input to the architect, this is input to the next person. So like that, what does he do? He constructs the building structure. Like that, you go through different people. So you go through plumber, electrician, carpenter, painter. You go through various stages. Then only finally your house will be ready. Only once you go through all these stages, your house will be ready. The similar to this, similar to the house construction flow. Okay, we have got various stages in ASIC also. So ASIC design flow also consists of 15 steps divided into two major categories. One is called as front end domain, the other one is called as backend domain. Front end domain starts from where? Design requirements. What do you want in your electronic device? Let's say you want to manufacture mobile phone. Let's say you set up a company which manufactures the mobile phones. What will you do? First, you will list down what do you want in your mobile phone, like what kind of processor, what kind of display you want, what kind of audio you want, what kind of camera subsystem camera you need in your mobile phone, how many megapixel camera do you want, everything you will have, right? That is called as design requirements. After that, whom do you think will go? Please tell me. Like in the house construction, we went to someone, house architect. Here, whom will you go? You go to architect. Next step is called as architecture. Once architecture is done, you will get it designed. Whatever architecture you have got, you will get it designed by using RTL design. RTL stands for register transfer level. Once the design is done, you go for integration. You will do the integration. Then whom do you go to? You do the functional verification. See, you went to you got the requirements, then you got the architecture, then you have done the design thing, then you went to the integration stage, then the functional verification stage, then finally you do something called as design for testability at the verilog RTL level. So these are the different aspects that happen in the front end domain. So what are the different aspects? Let's list down. Can someone tell me what is the first step in the front end domain? Requirements. Next, architecture. Next, what is the next stage? RTL design. Next, you have integration. You are designing everything. Okay, you integrate everything, you put together everything. That is called as what? Integration. Connecting everything together is called as what? Integration. Once you have done integration, what do? You need to do the verification, right? Whether it is it working properly or not. You have to check whatever design you have developed, is it working or does it has any problem. That step is called as what? RTL, functional verification. Then you do something called as design for testability, that is DFT at the verilog RTL level. Once it is done, what is the next stage you are going to do? Tell me. Once the front end domain is done, what is the next stage we are going to do? The next stage you are going to do is backend domain. The next stage is called as backend domain. Backend domain starts with synthesis. Can someone tell me what do we do in synthesis? What we do in synthesis? Can someone tell me? It is process of converting our Verilog code, whatever we have developed in Verilog code, into gate level format. Like convert the Verilog RTL code into gate level format is called as synthesis. Then we do DFT at the gate level, design for testability at the gate level. Then we do physical design. Then we do static timing analysis. Then custom layout, physical verification. Once you are done with physical verification, we extract a information called as GDS2, which stands for Graphic Design System 2. 2 means second type of version. This is extracted. Once it is extracted, using the GDS2 file, the fabrication is done. Once the fabrication is done, it goes for post silicon validation. Whatever chip you have manufactured, is it working correctly or not? It is checked at the post silicon validation. Finally, it gets packaged. Once you've done the packaging, this is how your mobile phone will come like. I'm just taking an example of mobile phone. It can be anything. It can be a laptop also. It can be even a laptop also. So majorly, if you see, the ASIC design flow can be divided into two steps. Each step can be further divided into some aspects. So what are the various stages in backend domain? Synthesis, DFT that you do at the gate level, physical design, static timing analysis, the custom layout, the physical verification, the GDS2 extraction, the fabrication. Once the fabrication is done, like the chips are getting fabricated, small chips, that you are checking, that is called as post silicon validation. Finally, once those things are done, you do the packaging finally to get your mobile phone like this. Next. Now let us talk about the VLSI front-end domain flow. Let's talk about the VLSI front-end domain flow. Let me be very quick. I think see, the front-end domain flow is what? This part, right? This is the front-end domain part. Okay. The front-end domain flow is very similar to a software engineer job. I mean similar. I'm not telling same. What does a software engineer does? It is similar to that. What is the skill set required for a software engineer? He needs he needs to learn languages like C, C++, and Java. They should be Software engineers should be good at reading the software specifications. They should be good at reading the software specifications, like develop algorithms, implement those algorithms using C or C++ or Java type of languages. Have you understood what is the skill set required for a software engineer? Other than that, they should be good with algorithms. They should have good programming skills. Did you all understood what is the skill set required for a software engineer? A software engineer needs to learn languages like C, C++, Java. They should be good at reading the specifications, understand the algorithm, develop the algorithm, implement that algorithm using these languages. Similarly, someone who want to get into front-end domain, that is VLSI, front-end domain engineer, should be learning languages like Verilog, SV, and UVM. So Verilog is similar to C language. System Verilog is similar to C++ language. UVM is kind of similar to Java. Similar, okay, I'm not telling same. So you need to learn languages like Verilog and SV and UVM. The hardware engineer should be good with programming, or even if you are not good, you should be having inclination to learn the programming. Okay, someone who want to get into front end domain should have willingness to learn the programming, like languages like Verilog, SV, and UVM. You should be good at reading the hardware design specifications and understand the functionality. Read the specifications, read the design specification, and understand the design functionality. And implement requirements using different protocols like USB, the PCI Express, the DDR, AMBA, different types of protocols you have to learn. So if you want to get into front end domain, let's write down what skill set you require. VLSI front end domain, what is the skill set required? Can someone tell me first, what do you need to learn? What languages do you need to learn? Can you tell me? Verilog, system Verilog, UVM. Okay. You need to also learn protocols like AXI, APB, SPI, I2C, USB, kind of protocols you need to learn. You should learn how to use above languages. So basically, I mean, just to brief, this is the level of expertise you need. Should be good with design and verification concepts. Who want to get into front end domain. Now let us talk about the backend domain. Someone who want to get into VLSI backend domain, no programming required. No programming skill set required. No need to learn any protocols. No need to learn any protocols. Means no need to learn AXI, APB, any kind of things. Okay. Then what is the skill set required? What skills are required? They should be good with semiconductors and CMOS, FinFET technologies. They should be good with what? Someone who want to get into backend domain should be good with what? They should be good with understanding of semiconductors, CMOS, FinFET, all those things. Other than that, they should also have good understanding of IC fabrication steps. Means understanding of what is lithography, what is oxidation. So various steps goes into fabrication process. They should be good with those things. Other than that, they need to have good expertise with softwares, EDA tools. EDA stands for electronic design automation. What does EDA stand for? Electronic design automation. So someone who want to get into backend domain should have good expertise with EDA tools. You might have heard like tools like Cadence Virtuoso or Model Sim, um, Design Compiler, or Prime Time. Different tools you'd have heard. So you should be good with using those tools when you want to get into the backend domain. Like some synopsis tools will be there, cadence tools will be there. You should be good with those tools. That is the skill set required for backend domain. So can someone tell me how many domains are there in VLSI majorly? VLSI majorly has how many domains? Two domains. One is the front end domain. One is the backend domain. Someone who wants to get into front end domain should have
inclination to learn programming. Should have inclination to learn programming. Okay. Someone who want to get into backend domain, no programming skills required, but should be good with technology based concept. I mean, should be good with tools and technology concepts. For example, what is meant by technology? I will ask you short channel effect, okay. CMOS latch up. You should be able to explain antenna effect. I'm just telling you, okay. Don't think that I'm expecting you to know what is short channel, what is CMOS. I'm telling you what kind of technology expertise, what kind of expertise you need to get into backend domain. So is everyone clear with the differences between front end domain and back end domain? Okay. So I have given you a brief of what skill set are required also. Okay. Next, we have talked about these things also. We have talked about domains. We have talked about front end domain. Okay. These are the different job roles in the industry. If you go through it, the person who works on the requirements is called as marketing team. The person who works on the architecture is called as a chip architect. The person who works on RTL coding is called as RTL design engineer. The person who works on integration, RTL integration, is called as RTL integration engineer. The person who works on functional verification, RTL functional verification, is called as functional verification engineer. The person who works on DFT is called as DFT engineer. Like that, for every domain, there are different engineers out there. See, these are the different people who work into the team. Now, in my case, for my 14 years of my career, 14 years of my experience, I only did this work, nothing else. I started my career in 2005. I stopped in 2019. For that entire duration, I only worked on functional verification, nothing else. So that means you don't need to get into VLSI job, to get into a VLSI job. You don't need to learn. You don't need to learn everything in VLSI. You have to choose one domain. You have to choose one domain. Like either you choose functional verification, either you choose RTL design, either you choose physical design, or you choose DFT or layout, and you should become expert in the domain. It could be physical design, it could be DFT, it could be functional verification. You should become expert in one domain. People, companies don't hire if you know the flow. Let's say you say I know RTL design, I know integration, I know verification, I know DFT. Companies don't hire. They will hire only if you are expert in one specific domain. That is where you have to choose between, should you go to front end domain, should you choose a career in back end domain. Tell me, when will you go to front end domain if you are interested in programming? Okay. When will you go to backend domain? You don't want to do programming, you are more inclined towards tool and technology job. You are more interested in tool and technology based jobs. In those cases, you go for backend domain. uh, okay. DFT overview, let's not go through DFT and all that for now. Next thing is, okay, let's now talk about career opportunities in VLSI. Okay. Okay. First of all, people ask which domain has better opportunities. It's like, right? VLSI is about what? VLSI is about development of a chip. There will be work for there will be work for both front-end domain engineers and back-end domain also. Both front-end domain and back-end domain will have the work. Given that there will be opportunities in both front-end domain and back-end domain. Okay. Next, so in that case, how do you choose? If you are interested in programming, you have done any programming languages like C language or C++, and you are comfortable with that, then you can go for front-end domain. Otherwise, you can go for back-end domain. I will say front-end domain, you can think of around having 60% opportunities. Okay, maybe around 55%, small percentage higher. Back-end domain having around 45% opportunities. Means there will be little more opportunities for front-end domain compared to back-end domain. Most of the time, there will be little more people required in the front-end domain compared to back-end domain. Okay. It could, you can say 55 to 60%. This you can say 40 to 45%. Okay. You can choose career in any domain here. Means to say what? You can even choose your career in front-end domain. You can choose to become functional verification engineer. You can become a physical design engineer, layout engineer. There are majorly there are 5 domains, 6 domains, I will say, of VLSI where freshers are hired. First thing is RTL, functional verification, is one domain. Second thing is DFD. The third thing is physical design. Fourth thing is custom layout. The fifth thing is physical verification. The sixth one is post silicon validation. So these are the 6 domains where freshers are hired generally. Other domains, mostly companies hire experienced engineers. What does it mean? If I take architecture, okay, if I take RTL design, RTL integration, formal verification, synthesis, STA, these domains, companies will hire the experienced people. See, can they give architecture work to the fresher, someone who is freshly out of a college? Can a company give him architecture work? Is it possible? Not possible, right? Someone who is a fresher, companies won't give him the architecture work. Same thing, the design work, they don't give it to the freshers. They will give it to experienced people. Synthesis also, STA, okay, and formal verification. These are all given to experienced people. So tell me in totally how many domains are there where a fresher is generally hired? How many domains are there in VLSI where a fresher is generally hired? 6 domains. What is the first domain I talked about? Functional verification. What is the next domain where fresher is hired? DFD. What is the third domain? Physical design. What is the fourth domain? Layout. physical verification, post-silicon validation. So these are the 6 domains where freshers are generally hired. Okay. This domain requires programming expertise. Which one require inclination to learn? Inclination to learn programming. Okay, you do, even if you don't know programming now, no problem, but you should have inclination to learn. Understand? Inclination to learn the programming. These domains don't need any programming expertise. They don't need any programming expertise. They are mostly tool and technology oriented jobs. Next, let's now talk about how to prepare for the VLSI jobs. I mean, choosing the right domains, I have told you, right? I hope you got an idea how to choose the right domain. Now let's talk about how to prepare for VLSI job. Okay, you should start your learning from the basics. See, understand, freshers are hired based on their expertise with the basics, with the VLSI basics. You don't need to know very complex things. They don't expect, companies don't expect very complex things or advanced things, very advanced things from fresher. You are expected to be good with the basics. So what are the basics? When I say basics, what am I talking about? I'm talking about you should be very good with digital design, digital electronics, analog design concepts. If you are getting into front end domain, you should be good with Verilog. Okay. So like that, there are some basic fundamentals are there which you should be good with. What you should do is you should spend some amount of time. Let's say you are pursuing your 3-2 or third year or fourth year. Accordingly, you have to split your time, learn Verilog, system Verilog. Even if you don't know UVM, that's okay. But you should be very good with VLSI flow, digital design, CMOS basics, Linux. Some scripting languages need to be learned. Okay. Most importantly, your emphasis should be on practical things rather than theoretical. I mean, your learning should be more focused on practical aspects, not the theoretical aspects. For example, Verilog, you are learning how to use Verilog practically, how to develop a design using Verilog, how to develop a test bench using Verilog. That should be the emphasis. Rather than learning what is always block, what is initial block, what is a task, what is a function, you should more focus on how to use Verilog for design purpose, how to use Verilog for verification purpose. So that is what I mean by you should give more emphasis on practical aspects than theoretical. This is a very brief about how to prepare for the jobs. Next. uh, what other skill set you require? I mean, just to start, okay, you should have, of course, the good communication skills. You should have a good aptitude. Aptitude means the simple aptitude questions will be there, right? The work and time, the distance traveled, different categories of questions will be there. You should be good with that aptitude skills also. You may say how aptitude is related to VLSI. Every job requires you to think logically. So aptitude will tell you how logically you can think about a problem. So these are the skill set that you require. Next, why VLSI job? Can someone tell me? I mean, those who are attending, what is your motivation for VLSI job? Why do you want to get into VLSI domain? Why do you want to get into VLSI? Because for many of you, you are already electronics engineers, right? EC or triple E or instrumentation. Your whole idea is to become a hardware engineer. I mean, your idea is to develop, why you are studying electronics engineering, because you want to develop the hardware which can make the life convenient for other people, right? You are responsible for developing the hardware which makes the life convenient for other people, right? So that is one of the primary driving factor for you. See, the first thing is you get that work satisfaction. You get work satisfaction because you do the work what you are studying now. Whatever you are studying, that is the work you are doing. Talking about career opportunities, there are a lot of opportunities. Like VLSI has almost 50 plus product companies, 100 plus service companies are there. Service based companies are there. So you get opportunity in all those companies. And there is no significant requirement for reskilling once you get into job. For example, whatever skill set I learned during 2005 to 2007, like I learned Verilog at that time, I learned System Verilog. Okay, then I learned UVM. That skill set, what I learned during that time, is applicable even in 2024 also. Today also I use Verilog. Today also I'm using System Verilog. Today also I'm using UVM. So I don't have to do lot of upskilling. See, whereas in software job, you have to do lot of upskilling, reskilling. A software job requires reskilling or upskilling every 3 to 5 years. Otherwise, you won't be relevant for the job. Every 3 to 5 years, you have to keep upskilling or change your skill set. And VLSI jobs are well paid jobs. See, 5 years experience engineer earns anywhere, I mean, in fact, more than that actually. Could anywhere earn up to 40, 50 lakhs also. 5 years, well experienced engineer, 5 years experienced engineer in VLSI earns anywhere between 15 lakhs to 40 lakhs per annum. So these could be some of the motivating factor for you to get into VLSI. So this was a brief about what is electronic system, what is VLSI, what is ASIC, and what is FPGA, different domains in VLSI, and then what is front-end domain, and what is back-end domain, and also we talked about the skill set required for VLSI domain. Okay. Now, if you have any questions, we will go through the questions. How many designs are in VLSI? Uh, Ash, there will be hundreds of design. Everything is a design, right? For example, mobile phone is a design, laptop is a design. Okay, a router is a design. Everything you are using, even a washing machine has a design, electronic design. So everything is a VLSI design only. Is it what you wanted to know, or you have some other question? Do you have some other question? Okay. Any other questions you have? Is the process, let's take this question. Is the process of front and back end same for I told you, right? It is not same. Let's take some other questions. What are the career opportunities in India? Any other questions? Please post your questions in the chat window. Please post your questions in the chat window. Okay. I told you, right? The front end domain is same. Front end domain process is same for ASIC and FPGA. It differs. It differs for backend domain. Okay. Because in ASIC, you're doing everything from scratch. In FPGA, you have a board. Sorry, I think I didn't share my screen. Sorry. Sorry. Front end domain, the process is same for ASIC and FPGA. It differs, okay, for backend domain. It differs for backend domain. Next. Career opportunities in India. Okay, let's take some other questions also. And what about abroad opportunities? And what is the best sources to learn VLSI? Okay. Any other questions you have? Okay. So let's first talk about the career opportunities where we can start learning VLSI. Okay. First, let's take the first question here. Career opportunities India. A lot of opportunities are there. I would say one statement here. Almost 60% of global VLSI workforce is based in India. 60%. Mean if whole world, assume example, if entire world has, let's say, 1 lakh or 2 lakh VLSI engineers, we can easily say 1.2 lakhs are only present in India alone, are related to India-based companies. Essentially, 1.2 lakh people, that is how many opportunities you have in India. You see, right, every company is there in India. Intel, Qualcomm, Broadcom, Nvidia, ARM, every company you can think of is present here. And they hire a lot of people in India because why? Simple. The same work, what I mean, see, let's say example is what they pay in USA for a 10 years experienced person. They have to pay almost 2.5 lakhs dollars USD, which translates to roughly how much? 2.1 crores. Same 10 years experienced person in India, same in India, he will get something like 40 to 70 lakhs. So which one is cheaper? I mean, which is the place where they can get the work done at a lower cost? India, right? That is where you see 60% of the global workforce is present in India only. Actually. Next, what about abroad career opportunities? It is good. It is also there. It is good. But my suggestion to you is don't go immediately after, don't go for MS immediately after BTech. This is based on my experience from the prior students. Don't go for MS immediately after BTech. It won't be helpful. At least work in the job for 2 to 3 years. Work in job in India. Then do masters. Then go for job there. Or you can even directly go for H1B visa without master, without masters. This will be the right way. Otherwise, what happens is if you go directly to MS after BTech, there will be a lot of competition. There will be working people who will also do MS. People with 2 to 3 years experience will come for MS. They will get jobs easily compared to a fresher. Okay. I hope it answers your question. Nishita, Dilip, is it clear to you? Next, what are the best sources to learn VLSI? Best sources to learn VLSI is there are, I have seen, now depends upon whether you want to learn VLSI front end domain or back end domain. There are some sources. Uh, One is you go to, I think, back front end domain. I've seen one website called testbench.in. I don't know whether how active is it now. Testbench.in is one place where you can learn the verification related things. Okay, I'm showing. Oh, I don't know. It is not there now. They have taken it down. So I can share some resources. I mean, probably earlier at the time where I used to refer, there used to be something called as testbench.in, or you can learn something called as verification academy is there. Verification academy is one thing where you can learn for free. You just go and do verification academy. It is one place where you can learn for free. See here, everything will be there. System Verilog, UVM basics, UVM methodology. So you can go here and learn the verification related things. So you can create your login here. There will be option for you to create a login, I guess, and through that you can learn by registering here, by creating an account. You can do this. Okay. Other than that, for backend domain, I think there are some other things are there. Um, some VLSI expert, STA, some these things will be there. Okay, VLSI concepts will be there. From here, you can learn the backend domain concepts. Okay, I mean, if you want to gain expertise in backend domain through these pages, you can do. I think VLSI Academy, I haven't tried. It's free. Ash, I think VLSI Academy is free. Okay, so these are the different sources you can learn from. Uh, any other questions you have? Actually, see what happens in my case, we don't explore the sources because as a training institute, we develop our own resources, right? So there we don't refer to other places. So that's the reason I'm not very uh, clear about which all pages are there to learn everything. Any other questions you have? uh, One more thing is, in case you want to do, some of you might be pursuing 3-2 or so. In case you are looking for internship also, we at the VLSI group offer internships in collaboration with some companies, some VLSI companies, other VLSI companies. Next. Okay, someone asked a question about how to get a job in VLSI for fresher. What are the skills needed? See, first of all, I told you that you have to choose between whether you want to get into VLSI front end domain or you want to get into VLSI back end domain. If you front end domain, if you want to get into, you have to learn digital design perfectly. You have to learn Verilog. You have to learn system Verilog. You have to learn UVM. Okay, some protocols and projects based on these protocols. If you want to get into backend domain, you should be good with digital design, should be good with semiconductors. Okay, and then you should be good with IC fabrication, and the flow tools and technology. Tool flow should be, you should be very good with the tool flow, how to implement the flow, everything you should be good with. Next, how do I apply for internship? So I would suggest please connect with our team at this number 194 191 for, I mean, you can WhatsApp them or even call over phone for more details. Next, what are some good companies where I can expect to get into as a fresher? See, majorly there are two types of companies. One is product companies, one is services companies. As a fresher, product companies generally hire people from tier 1 college, tier 1 or tier 2 colleges. Okay, don't take me wrongly, but mostly as a fresher, you can start your career with services companies, work in this for 1 to 2 years, then you can move to product company. It is possible. I mean, if you talk about companies, there are so many companies: Wipro, HCL, Tech Mahindra, Mirafra, UST Global. So many companies are there in services, and so many companies are there in product companies. It's all possible. Shakti, is it clear to you? Okay. Any other questions you have? Okay. So we will conclude here. I have one request. I want you to share your feedback because we plan to run this kind of VLSI awareness sessions. I mean, idea of doing this 1.5 to 2 hour session is to give you a brief awareness about what is VLSI and all that. Uh, Other thing is, I mean, talking about VLSI, is it difficult to, is it very difficult to get a job in VLSI? Get a job in VLSI? Answer is no. It's not very difficult. Ideally, my suggestion is you should consider joining some training program. Okay. Reason being, most of the time, whatever skill set you learn in your college, BTech time, that is not sufficient for the industry. And you should complete everything properly. Like I have given you the skill set, right? You should become expert in that. Then you can easily get a job in VLSI. The advantage of getting into job into VLSI is the salaries are high. You will have a lot of work satisfaction, and you don't have to reskill frequently. I mean, whatever you learn now will be relevant for 10 years later also. Okay. So that was a brief about it. So, I mean, as I said, we plan to run this kind of VLSI awareness programs. So I want your feedback. So I request you to fill the feedback form so that we can understand whether is was this session useful. What else do you think we could have done to make it more informative for you? Okay. So please take out few minutes and fill that form. That will be very helpful for us. Okay. Thank you so much. Do you have any questions before we end the session?